Okay, looks like we're up and running. I'm gonna keep the lights off because I'm trying to keep the glare off the board. Yeah, I think full screen here. Looks good. All right, I got a nice marker. Should project well. So this is rapid fire 5. I am gonna do graphing form for quadratics and sketch. I'm gonna do some factoring and setting products equal to 0. Going to do a little work with square roots, conjugating and simplifying. And it looks like a little functional notation and some work with imaginaries. And I'll try to do them in that order. All right, so you move around to wherever you think you need to spend a little more time to try to put another topic in your back pocket. All right, so how do we sketch something like 2x squared plus 20x minus 3? Put it in graphing form. You don't have to sketch more easily, actually, doing some other things. We're going to put it in graphing form. So, and then we'll sketch it to the side. We'll do 5 in a row. And I'm not going to talk too much. I'm just going to rapid fire, do 5, and hopefully about the 5th one, you're having a little more success. All right, so you're always going to pause the video, try it, then watch it, so on and so forth. All right, so to get this in the graphing form, you might as well take the first gift. First gift is using the doubling of the squaring process. Now we need to find the vertex, and the vertex can be found by x equals minus b over 2a. And in this case, that's minus 20 over 2 times 2, which is equal to negative 5. So therefore, we're going to say x plus 5, because the smallest area that you can have is very tiny, it's 0. So I want that number to make 0 squared. And then all we got to do is plug in that number to find the y that goes with it. So we'll plug in negative 5, which gives us 2 times negative 5 squared plus 20 times negative 5 minus 3, which gives us positive 50 minus 100 minus 3. I look at the first two numbers. They have different signs. One's positive, one's negative. That's good. And the middle term's twice the size of the first term. That means I've got the right number. And so this is minus 53. So what do we have? We have a cut shape up. Negative 5, negative 53 is the vertex. Negative 53, I'll have to put it there. Negative 53, and immediately we know what the y-intercept, because you always want to make product 0. Negative 5 makes the product times 2 0. Using 0 gets that product out of there. Negative 3 is the y-intercept. 0, negative 3. This is always this is on the increasing side. This is decreasing. I know there's an arrow there, but decreasing, increasing. If I'm on the increasing side, it means the coefficient of the middle term is positive. I look and I go, yes, positive 20. Everything matches up nicely. And now I'll do 4 more without talk. All right, I think I'll do y equals negative 3x squared plus 12x plus 10. I'll take the gift. I'll do minus b over 2a, which is positive 2. So I'll write minus 2. I'll put positive 2 in. I get 12, negative 12, plus 24, plus 10. I see what I wanted to see, so I know that's a correct calculation. So that's half of the middle term, or the opposite of the first. 12 plus 10, 22. I now can see cup shape down, because that's negative. I can see the vertex 222. I know 0 is on the increasing side if I look at that number, but I also know that 0 is to the left of 2. And I know that's the y-intercept. And if you give me the shape, the vertex, and the y-intercept, you've got a correct graph. Next one. Go back to the positive. Y equals 3x squared plus 24x minus 7. Let's try that. 3x squared plus 24x minus 7 And so what do we have? We have the gift. Minus b over 2a, which in this case is equal to -4. So I write +4. I know that a 0 gives me -7. Right now, a 0 gives me 48. So I don't want 48. I want -7. That's another way to get that number. Or you can plug in -4, which is -48 plus 96 minus 7, which is 48 minus 7. Did I do that the last time? I feel like something was off here. Yeah, I think. See, I want -4. Yeah, that's my problem. I want it -4. Little error there. -4 squared, so this is positive 48. That's minus 96. Minus 7. Okay, so that's going to be minus 48 minus 7, which is minus 55. So I see positive, I see cut shape up. What makes a 0? -4. What goes with it? -55, because if I make the multiplication 0 by using this number, I'm left with that number. 0 is to the right, so my middle term should be positive. It is positive 24. And I'm actually going up from 24 to 1 right there. If we took out a little nitrogen stove and did a little y2 minus y1 over x2 minus x1. So 0 gets me the y-intercept, -7. Okay, that's the third one. Let's go back to minus 2x squared. Let's go about plus 40x minus 7. I take the gift. I do minus 40 over -4. I get 10. So I write x minus 10. That makes it 0. If I use that x value, 0 squared is the smallest. And we can either have a max or a min based on the smallest. Where am I? I'm using the number 10. So if I put a 10 in, I get minus 200 plus 400 minus 7, which is 200 minus 7, which is 197. I see a negative, it's cup shaped down. I see the vertex 10, 197. 0 is on this side on the increasing, so again, it's a positive 40. So 0 gets us -7. Arrows would be nice. And 0, 10, so 20 also gets us. If you wanted to have symmetry there. Last one. Let's do 5x squared plus 10x minus 9, like that. So we got the gift. We got minus 10 over 10 is -1, so I write +1. That makes 0 squared times 0. The y-intercept, I don't want that. I want to figure out what goes with -1. This is 5, this is minus 10, this is minus 9. I like the look of that. So that's -5 minus 9, which is minus 14. Cup shape up. Vertex, -1, -14, 0's to the right, so positive middle term, yes, positive 10. Probably should have done some negatives, that's okay. And so that's the y-intercept. Changed it from ax squared plus bx plus c to a times x minus h squared plus k. That's just as important as saying y equals mx plus b, right? It's just, it's a graphing form, that's a graphing form. I don't like this graphing form. I wish that linear functions were written as a x minus h plus k. I wish you'd started there because that becomes templative. But the books have been written for hundreds of years. You keep doing what somebody did the first time. Unfortunate. The whole study needs to change, in my opinion. But very, very, who knows me opinion. Factoring. Oh, I don't have the actual numbers, the specific numbers, but I do remember the topics. So how would we write x to the third minus x squared as a product? And how would we write something like x squared minus 5x minus 14 as a product? Well, the first rule, rule number one, take out what's common. There's only one problem with rule number one. You don't always use it. And here's a good example. I'm not going to use it here because there's nothing common. If that was an x, yes, they all have an x in them, but this one doesn't. Okay, is there something common here? This is x cubed, that's 3 of them. There's 2 of them over here. Do they share anything? Yes, they share x times x. So it's usually the smaller exponent that tells you what's common in this type of polynomial. So what does x cubed minus x squared get us if we write it as a product? X squared times x minus 1. Now, what's the beauty of writing it in that form? Well, one of them is, what if I was divided by x minus 1? Which one of these fractions looks easier to reduce? Hope you said that. All right, so now this doesn't have anything in common, but you still consider the first rule. But these do come from the FOILing process, and I do know that x times x gets me x squared. God, I hope I'm not running out of ink. And we're looking at factors of 14 right here at the end. To get minus 14, I need, one of them's got to be negative, one of them's got to be positive. There's only 2 factors, 1 and 14 and 2 and 7. Now, which of those factors has the number 5 showing up? I hope you look at that. And how do you add those up so you get negative 5? And that better be a negative and that better be a positive. So positive 2 minus 7. And now you've got yourself something in factored form. How might that be helpful? Well, it might be helpful if we consider this concept. Length times width, which is a product, equals area. Now, what if the area, length times width, was 0? Well, what happens if the area is 0? Oh, marks. All right, I'm going to have to run into a classroom in a minute. I'll make sure you can see this. Well, here's a length. Here's a width. And if that product is 0, here's the area. Well, that area has to disappear. I think it disappears if we keep getting rid of the width. There's no width. So I guess I want my width to equal 0 or my length to equal 0. Because if you take one of the dimensions away from a rectangle, you got no area. Well, could we make this length times width equal 0? Think about it that way. And apply the same concept that one of the dimensions has to disappear. Well, length is showing up as a parenthetical statement. Then I think I need that parenthetical statement to equal 0. Yes, that gives me x equals negative 2. And if I want x minus 7, which is representing the width, to equal 0, what number gets rid of the width? You said 7. You'd be right. And we could have done that over here, set that to 0. Well, would be nice if we could write that as a product, because we could do the same thing as over here. And we said that's x squared times x minus 1. Well, that's length, that's width. I could add another product. Height. Looks like I got volume now. But if all I did was set it to 0, either x squared could equal 0 or x minus 1 could equal 0. And then you're actually solving some equations. To this point in time, we've been solving equations with inverse operations, but this isolates some statements as well. Products isolate statements. And if you know length times width equals 0, then either that's 0 or that's 0. It's got to be true. Let's try another one. So let's write 2x squared minus 5x as a product. And you're pausing the video. I'm sneezing and then going ahead. No, yep. ICX is common. That's the product. If we set our product to 0, can you see the answers? Twos cancel, fives cancel. 0 times anything is 0. Now let's see if we can get x squared minus x minus 6. Well, nothing common. So it could be a trinomial. That is a trinomial. Could be expressed as a product of binomials. Two numbers that multiply out by 6 and are 1 apart. Well, those numbers popped into my head, and I want the negative. Well, there's your product. When does this equal 0? I can't immediately see. When does this equal 0? I can immediately see. 3 and negative 2. If this is 3, you do the math. I hope you can see 0 times 5. Something in my throat here. All right, so that's 2 problems. Let's try another one. Let's write a b squared minus a to the 4th b to the 7th. Let's put a 4 in front of this. Let's put a 12 there. And we're just practicing writing product. Well, do 4 and 12 have something in common? Yeah, 4. I guess that's minus 3, huh? 4 times minus 3 is that. 4 times 1 is 4. I don't think I need to write that one right now, because there's more things in common. A and b squared. That's what's common. I think I need the 1 now in order to get that. And I think I need a to become a to the 4th. So that's got to be 3. And I think I need 2 of them to become 7. I guess that's 5. I'll put the 1 there, read a little better. You do that multiplication, and you'll see it comes back to that. Now let's try 8x squared minus 4x to the 5th. We'll write that as a product. And then we'll write x squared minus 7x. Let's make it plus 7x. X squared plus 7x minus 18. We'll try to write that as a product. Well, what's common here? X squared is certainly common. 4 and 8, 4 is common. So I guess I got to figure out what will get me there. Said 2, you'd be right. And then I got to figure out what do I multiply by to get that? Well, I guess I have to have a negative. I have 4 times a negative. Now I've got the 4. Now I got to go from x squared to x to the 5th. That's that product. Then I look over here and I say, what's common? I don't see anything common. So I wonder if I can do one of these, x and x, and then ask the question, what times what gets me negative 18? If I also added them up, what gets me positive 7? So factors of 18 that have something to do with 7. I hope your brain comes to 2 and 9, and I need one of them to be negative. Well, who wins out? The positive? And I'll make the 2 the negative. And you should FOIL this now. So if I make that the negative, then that's the positive. Like, oh yeah, that's 9x minus 2x. That's 7x, all right. Seems to be working fine. Of course, if I set it to 0, I actually know the roots of a quadratic. I already know the roots now. I have a quadratic that goes through at 2 and at negative 9. And if I put a 0 in, I can find the y-intercept. Oh, it's negative 18. Oh yeah, it was here all along, wasn't it? All right, so I don't know how many of those I just did, but that's going to show up tomorrow. Feel like I did enough of those. I hope I did. All right, so we have 7 over root 3. This is a skill that will disappear, but We don't like dividing by irrationals. Right, I know it's approximately 1.73, but this thing goes on. So what would get rid of that? Multiplying by √3 over √3. So that becomes 7√3 over 3. I don't care if you leave that like that. Computers can handle that now, so I don't think this skill is going to stick around forever. Now that we have machines that can handle this. But what's in the textbooks and what you might have to take as a standardized test question, maybe to get into a college course, what level? You're going to see things like 4 over 5 minus √2. So what's going to change that? Multiplying by 5 plus √2. 5 plus √2. So let's go ahead and do that. 4 times 5 is 20. 4 times √2 is 4 √2. 5 times 5 is 25. The middle terms we're going to cancel, right? You got minus 5 √2, and then you got positive 5 √2. So 5 times √2 is 5 √2. I'll do it once. Minus √2 times 5 is minus 5 √2. And minus √2 times minus √2 is minus √2 squared. And what is minus √2 squared? Minus 2. Okay, so what does this become? This becomes 4 times 5 is 20. Right, it's in parentheses. 4 times √2 is 4 √2. And now we're dividing by 5 squared. 25. √2 times √2 is 2, so it's minus 2. So there's your 23. Try another one. Let's try 9 over 7 minus √5. So you're going to multiply by 7 plus √5. 7 plus √5. Get tired here. So 9 times 7, 63. 9 times √5, 9 √5. I don't know how to simplify that. But this is the plus minus form, so no middle term. 7 times 7, 49. By definition, √5 times √5 is 5. And a positive and a negative make a negative. And so that becomes 44. And I don't think I can reduce that because I can't write these products in any other way. All right. So that's called conjugation. The ones you're conjugating more often are going to be things like 8 over 9 minus 4i. Okay, I'm not going to pause the video, but I am going to try to change the, yes, I have an orange one here. Let me just do this real quick. All right. There we go. We got that. We got that. Come on. Oh, boy, this one's tight. Should put it down. There we go. We got that. Take this out. Nothing spilled. That's good. We'll put this in. Let's hope that this starts to write better quickly. All right. So what's the conjugate of 9 minus 4i? 9 plus 4i. 9 plus 4i. Nothing hard about the numerator. 72 plus 32i. The denominator, 9 times 9, 81. Minus 4i times 4i, minus 16i squared. Pay close attention to that. That's where people make a mistake. What does minus 16i squared become? If I do I squared, it changes the sign of what's in front of it. And 81 plus 16 is 97. There, marker's starting to catch the ink. That's a good thing. Let's erase. All right, let's try another one. Let's do 7 over 5 plus 3i. And so parentheses, what do you multiply by? 5 minus 3i. 5 minus 3i. What's that equal? 35. Minus 21i. No common factors, so I'm not going to be able to reduce this. 5 times 5, 25. If you'll notice, you're always getting a minus. 3 times 3, 9. I times I squared. What does minus 9i squared become? Becomes positive 9. What's 25 plus 9 become? 34. Let's do one more. Let's do 5 plus 2i over 7 minus 3i. What am I going to multiply by? 7 plus 3i. 7 plus 3i. The numerator just got a little more challenging. So 5 times 7, 35. 5 times 3i, 15i. 2i times 7, 14i. 2i times 3i, 6i squared. Over 7 times 7, 49 minus 3 times 3, 9. I times I squared. What does that become? Well, that's positive 9 in the denominator. So that's 58. Addition of 6 is going to become what? Subtraction of 6. And what's 35 minus 6? 29. What's 15i plus 14i? 29i. No, that's coincidental. I think it is. Maybe there's something going on here. I don't know. Let's do one more and then I'll do it for that one. Let's do 4 minus 7i over 3 plus 2i. What do we multiply by? 3 minus 2i. 3 minus 2i. Put parentheses around everything. 4 times 3. I'll put it here, 12. 4 times minus 2i, minus 8i, minus 7i times 3, minus 21i, minus 7 times minus 2 is positive 14, I times I squared, all over 9 minus 4i squared. What can I do to minus 4i squared? I can change it to positive 4. What can I do with 14i squared? I can change it to minus 14. Now I can put things together. 12 minus 14, negative 2, minus 8, minus 21, I think is what it was. Minus 29, I over 13. Hope you had enough practice there to make some gains. What other imaginary work are we doing? Well, we're doing things like minus 3i to the 11th, positive 2i to the 90th. Minus 7i to the 43rd, 5i to the, let's do negative, let's keep positive, 5i to the 103, and let's do up here, let's do negative 6i to the 42nd. All right, so what do we know? We know I squared is negative 1. This is a building block. That knowledge allows us to simplify every single one of these. So how many I squareds are there in 11? If you said 5, you'd be right, but we need one more. All right, and what is I squared? Negative 1. And what is negative 1? 5 times, I won't write the 1, but the negative sign. Minus times a minus is a plus, a minus, a plus, a minus. So if the exponent's odd, it stays negative 1. If the exponent was even, what's negative 1 squared? Changes to positive. Right, so that was an odd, so it stays as negative 1. So what's our final answer? 3i. 2i squared. Well, I squared. How many I squareds are there in 90? 45. No remainder. So the question is, if you did negative 1 45 times, what would you get? You'd get negative 1. So if that's odd, then this whole thing becomes negative 1. And if there's no remainder, right, 2 went into 90 evenly, then our answer is negative 2. All right, so I got an odd to begin with. Not to begin with means my answer is either going to be -7i or +7i. Just sharing a pattern that I've seen over the years. It's going to be one or the other. Which is it? Well, you got to figure out how many times 2 goes into 41. 2 goes into 41 20 times. That's the key. If that's even, then -1 times -1 20 times is +1. Of course, I still need another I, right, to get to 41. So that becomes -7, -1, an even number of times is +1, times I. This answer was -7i. That's an odd number. That means I'm either going to get 5i or I'm going to get -5i as an answer. Why? Because 2 goes into 103 51 times. That's odd. That's going to make this a negative, and that takes me to 102. So I need to get to 103. I need another I. So that's 5 times I squared to -1. It's always going to be -1 in the parentheses. The question is, how many times are you doing it? Well, I'm doing it 51 times, so it's -1 still, times I, so -5i. Was that 42? That's an even number. I'm either going to get 6 or -6. Let's find out why. -6, because I squared 21 times. That's -1 to an odd number. What's my answer? -6. All right, you got a bunch more problems there. Let's practice. All right. Let's see, now we're going to just do some simple, get us started on square roots. Let's start with the square root of 18. Then let's go to, let's start with the square root of 12. Getting tired, aren't I? Then we'll do the square root of 18. Then we'll do the square root of 24. Then we'll do the square root of 40. And then we'll do the square root of 56. All right, so what's the easiest way to see this? Well, squares. 4, 9, 16, 25, 36, etc., etc., etc. Why is that helpful? Because I know another way of writing the square root of 12 is the square root of 4 times the square root of 3. Now, one of those square roots you can rename and the other you can't. Which one do you think you know the answer to? Do you know the square root of 4 or do you know the square root of 3? That's what you should have written for your answer, 2 root 3. 18, square root of 9, square root of 2. 3 root 2. Remember, you're pausing the video. 24, square root of 4 times the square root of 6. 2 root 6. 40, square root of 4 times square root of 10. 2 root 10. I don't think I get an immediate one that I see here for 56, so we're going to factor 56. Well, we'll do a little factor tree. 56 is 2 times 28. Oh, I see a number that fits into 28. That's 4 times 7. So this could have been written as the square root of 2 times the square root of 4 times the square root of 7. And I know one of those. Do you know one of those? I know that one. Boom. And what's an easier way of saying the square root of 2 times the square root of 7? What's a simpler way of saying that? Square root of 14. Okay. I hope that's enough practice with that. 2 more topics. Maybe it's just one. Could be just one more topic, f of x. All right, so let's do a couple of functions. Let's say f of x is equal to 5x plus 2. And let's say g of x is equal to x squared minus 7. All right, and so what's f of 3? Well, in class, I hope you know I gave you an x value. And what do you do with x values? You use them, and you get 17. 3 times 5 plus 2. Let's do g of x equals 10. Well, is there another name for g of x anywhere on the board? Anybody see another name? Oh, may be written, g of x may be written as x squared minus 7. That's what an equal sign means, may be written as. So what can I write g of x as? X squared minus 7. So what is that notation really asking you to do? Solve an equation. X squared equals 17. I bet the house on the fact that most people forgot to write plus minus. If you didn't write plus minus, you don't get one of those checks from me. Sorry. Let's do f of g of 2. Is there another name for g of 2? A simpler name? Is there a simpler name for g of 2? Oh, that's an x value when you use x values. So 2 squared minus 7, 4 minus 7, negative 3. Oh, g of 2 can be called negative 3. Can we do f of negative 3? Oh, I think that's negative 15 plus 2. Negative 13 is this answer. That's called a composite. Can we find f minus 1 of x? Well, I guess that's all about inverse operations. When do you use inverse operations? When you solve an equation. So 5x plus 2, I don't know, let's solve 7. How would you start that? Well, you'd start with the answer, which we're going to call x in this case. And then what do? I think addition of 2 becomes subtraction of 2. And multiplication by 5 becomes division by 5. You do the inverse of addition and you do the inverse of multiplication. How do we know if we're right? Well, let's actually find an x and a y. How about I put a 10 in and I get 52 out? If in the original, the 10 gets me 52, then down here, a 52 has to get me a 10. So let's see what we get. 52 minus 2, 50 divided by 5, 10. I think I found the right inverse. Okay, let's do that again. A couple of different functions. Let's say I give you f of x. Let's do 2x cubed minus x. And over here, let's do g of x equals 3x minus 8 over 5. All right, and how about you guys do f of negative 4? Well, I'm hoping that you're plugging negative 4 in and cubing it, and I hope you know that 4 cubed 64. I've been working with it a lot, but I'm doing it 3 times, so negative 64. If I double negative 64, I get minus 128. And if I subtract 4, looks like I get minus 132. And so all I did was put the number in negative 4, and I may have screwed up here. I think I subtracted. Now that I wrote it that way, I should have added, right? The old guy's getting tired. So let's go back and do this again. So that's negative 64 times 2 plus 4. Yeah, I'm changing my answer. That's negative 128 plus 4. I think I'm getting negative 124. And so that's better, right? Okay, let's do f of g of 3. I think I gotta do g of 3 first. Now you can see why I did 3. Of course, that's going to cost me over here. That's okay. So 3 gets me 9 minus 8, so that gets me 1/5. And so now I have to do g of 1/5. Nothing wrong with a little fraction practice. 2 times 1/5 cubed minus 1/5. Well, 1/5 cubed is 1 over 125. I'm going to double that and then subtract 1/5. Okay, I don't even want to bend down anymore. So this is 2 over 125 minus 1 over 5. Looks like I ought to make this 25 times bigger. Right, 25 times 5 is 125. So if I make it 25 times bigger, I now get 2 minus 25 over 125, which is equal to minus 23 over 125. And I'm just performing the calculation. All right, now let's see if we can do the inverse of G. The inverse of G. Well, if you were solving an equation, what would be the first thing you do? Well, I take whatever number that is, and in this case, I'm going to call it X. Right? So I'm using the answer to get back to what I started with in this case. And I think I'd multiply it times 5. Then I think I would add 8. And then I think I'd divide by 3. All right. So 3 got us 1/5. Why don't I put in a 1/5 in the inverse? Let's do the inverse of 1/5 and see if it comes back to 3. So I'll put a 1/5 there. What adds to 5 times 1/5? They're reciprocals. You get the number 1. What's 1 plus 8? 9. What's 9 divided by 3? Bingo. I did the inverse. Instead of going from 3 to 1/5, I looked at the operations that take me from 1/5 back to 3. All right, do another one of those. I keep losing track of how many of these we're doing. Okay, let's look at, oh God, let's look at f of x equals about 2/3 x minus 7, a linear. Let's let g of x equal, let's have some fun here, 5 to the x minus 2. Because you're gonna have to learn the inverse of that. So we'll do the inverse of that in a minute. So how about we do f of 9? Now let's do f of 10. F of 10. I can put 10 in here and I'm gonna do 2/3 times 10. What's the first thing I'm gonna do? I'm gonna double it and then I'm gonna divide by 3. That looks to be 20 over 3 minus 7. And what is 20 over 3? Need over here, I need division by 3. I need division by 3. The denominator, which was a 1, is now 3 times bigger. So the numerator needs to be 3 times bigger. It sure looks like minus 1/3 is f of 10. How about we do f of x equals 10? That's a different question. But I know another name for f of x. Can you see another name for f of x? Another way we can write f of x? Oh, 2x. Oh yeah, this is the calculation f. And I want to know when it equals 10. So what you're basically doing is trying to find out 2/3 x minus 7 when the table value over here reads 10. How are we going to do that? Inverse operations. What are the inverse operations? Let's do them one at a time. Let's add 7. Let's multiply by 3. Let's divide by 2. There's your answer for that one. And that's called solving an equation. Let's find the inverse of G. Again, I don't think this is one that you're going to have much success with yet, but I'm going to keep saying it. The basic calculation over here is 5 to the something. What's the inverse of 5 to the something? The inverse of 5 to the x happens to be log base 5 of x. Okay, so if I plug in an x value of 2, I hope you can see 25 on this side. If I put 25 in for x, I hope you can see 2 on that side. If I put a 3 in, I hope you can see 125. I got a feeling you can see that easier than putting the 125 here. All right, but what does a log ask? What's the exponent you put on top of the 5 to get a 125? And I hope you can see that this x, the x is in the y switch. The x is in the y switch. Okay. So what's another name for g of x? Really y equals, right? And if the x is in the y switch for the inverse, then why don't we switch them right now? And why don't we try to get y alone? What would be the first thing you do? Well, I got to get y minus 2 alone. I gotta change from exponential form to log form. It's gonna take you a while to learn that. Then I gotta do what? Add 2. And that's my new function. What's the inverse of something raised above a 5? Logarithm. So what's an easy number to work with? Why don't we work with 4? So 4 minus 2 is 2, 5 squared is 25. So over here, an x value of 4 gets me a y value of 25. Therefore, if this is true, then an x value of 25 should bring me back to 4. Let's see if that's true. Let's put a 25 here. What's the exponent you put on top of a 5? You get a 25. Yep, that's a 2. And 2 plus 2 is 4. Guess I did it right. So that was the inverse. Let's do one more series of those. Let's do g of x equals, how about x over 7 plus 9? And let's do h of x equals 2 log base 3 of x minus 4 plus 7. We'll end on that one. Almost done here. So, can you do g of 14? I hope at this stage, maybe number 14, divide by 7 is 2, plus 9 is 11. Can you do g of h of 5? No. Excuse me. G of h of... No, I know what I wanted to ask. Not asking the right question. I want to know when h of x is equal to 5. You have to forgive the old guy. I actually tried to do this video before and I had technological problems, so I put a half an hour in, got nothing out. As long as nothing goes wrong now, almost done. So what does it mean to do h of x equals 5? It means to rename this with what I told you h of x was, the calculation 2 log base 3 of x minus 4 plus 7 equals 5. All right, so how do we solve this? A series of inverse operations. So let's do the inverse operations over here for g, or for h. So h minus 1 of x is going to be a calculation. I'm not going to have enough room. Let's write it here. H minus 1 of x. So we'll start with some number. In this case, that number is 5. What's the first thing we're going to do over here to solve? Subtract 7. So I'll put a subtraction 7 there, and I'll actually do it over here. 2 log 3 x minus 4, subtracting 7 gets me negative 2. All right, so that 7's gone now. What's the next thing I'm going to get rid of? Multiplication. So that's log base 3 of x minus 4 equals negative 1. Because I did what? I divided by 2. So that's there. Okay, so that's gone. So now, how do I get x alone here? I got to undo log base 3. Well, the inverse of log base 3 is 3 to the. The inverse of 3 to the is log base 3 of. What's the inverse of 5 to the x? Log base 5 of x. What's the inverse of log base 7 of x? 7 to the x. Right? Exponentiation. You want to do the inverse of something in exponential form? You write it in log form. You want something from log form to not be in log form? You write it in exponential form. This is an example of exponential form. 5 squared equals 25. This is an example of the same connection of numbers in log form. So over here, this is your x and this is your y. Over here, this is your x and this is your y. And you can see they're reversed. They're inverses. So right now, I am in log form. I am log base 3 of x minus 4. And I want that to become exponential. Then that becomes, how do I want to say this? Well, it becomes a 3 to the x situation. Right, now where this becomes 3 to the x, which means that if let me move this to here. Okay, so I have written it in this form right now. So how do we rewrite that? Rewrite that as the exponent I put on top of the 3 is given to me. It's a 1, and that equals x. Oh, it's a -1, wasn't it? And that is a -1. And that has to come from the quantity x minus 4. Well, I know what 3 to the -1 is. It's 1/3. And that's x minus 4, subtraction of 4. So I gotta go finish this here. So I'm gonna move this over. H minus 1 of x. So what I basically did, log base 3 becomes 3 to the, where that becomes an exponent. Right? This is an exponent quantity. This is the quantity that came from the exponent. Talking way too much. Minus 4 becomes addition of 4, which means that when I bring the 4 to this side, there's my answer, 4 1/3. Let's check that out over here. Let's put 4 1/3 in here. What's 4 1/3 minus 4? 1/3. What's the exponent? Put on top of a 3 to get a 1/3. -1. What's 2 times -1? -2. What's -2 plus 7? +5. All right, so I'm getting a little squirrely here. I honestly don't remember how many of those we just did. Hopefully some practice for you. So let me end this video before it ends itself. And I have to make this again. Oh, wait a minute. What am I doing here? I don't want to end the video. Okay, I got to do that. All right, see you tomorrow.